Applications of equivalent ratios. For the most part, we're really good when we talk about using equivalent ratios to find another ingredient in a recipe if we're going to double it or triple it or take half of it. But what happens when we're trying to compare two different recipes or two different scales? So that's the application we're going to look at here. So we have Laredo, Franca, and Milton who are making cider for their upcoming Halloween festival. And we want to know whose cider would taste the strongest. So first and foremost, I want to highlight that question. So whose cider would taste the strongest? And we're going to go ahead and we're going to underline strongest, because in this case we have to know that strongest means it's going to have the most cider taste. So the most cidery taste. We'll just go ahead and pretend that that is a word. So in order for it to have the most cider-like taste, it's going to have more cider than the others compared to maybe the same amount of water. But when we take a look at these different mixes, we can see that there's really not necessarily a spot where they all have the exact same ratio of water or cider mix. So we have a couple of different options here. What we can do is we can go through the list and we can look and see where they have any mixes, so any cider mix that is the same. So for example, we have Milton and Franca, and Milton has 16 parts water to 6 parts cider, whereas Franca has 15 parts water to 6 parts of cider. So when they have the same amount of cider, Milton has more water. This means that his is going to taste more watery, which would then tell us that Franca's is going to be stronger. It's going to have more of that cider taste because with the same amount of cider, it has less water. All right, so then now looking at the next step, we know that that Franca's is stronger than Milton's. So now we have to take a look at how can we compare Franca and Laredo. And this one doesn't look like it's going to lend itself so nicely. So here I can look and I see I have 15, 20, 35, and 50 for my water. None of those match up. I have my cider mixes of 6, 8, 14, and 20, and none of those match up. Okay, and I know that we do have a spot here. We're going to pretend that we don't have this total column because I want to look at what would happen if we don't have a matching number inside of our different ratios. So now what I need to do is I'm actually going to take a look at how I can use equivalent ratios to help with this. So first and foremost, I can look at, do I have ratios that I can make equivalent somehow? So if I take a look at, I'm going to highlight here, I have 20 to 8 and I have 12 to 2. I know that I can get 8 and 2, so I can get 2 to 8 using equivalent ratios. So when I have 12 parts of water for Laredo and 2 parts of cider mix, I want to know what that would be equal to for 8 parts, because of the fact that Franca's, when she has 8 parts of cider mix, she has 20 parts water. So I know that I can multiply both of these by 4 because 2 times 4 gives me 8, so now they'll have the same amount of cider. When I do to one, I have to do to the other, and here I get 48. So what this tells me is that when Laredo has 8 parts of cider, he's going to also have 48 parts of water. Whereas with Franca, when she has 8 parts of cider, she's only going to have 20 parts of water, meaning that hers is stronger than Laredo's. Another way that we can look at this is if we take a look at all the different unit rates. So I can take all of these. Okay, so I found ratios that I could compare. I found where I could make equivalent ratios because I knew that 8 and 2 have a common multiple that's not that large, right? I also could have used 3 and 6. I could have used 7 and 14. I could have used 5 and 20. I could have used any of those options and my answer would have come out the same. Here I'm going to take a look at using what we call the unit rate, and we're going to talk about that a little bit more in detail in lessons to come. But we've talked about that unit rate being compared to 1. So we might end up with a decimal in these, and that's okay. So with Laredo, he has 12 parts water to every 2 parts of cider mix. Milton has 16 parts water to every 6 parts cider mix. And then Franca has 15 parts water to every 6 parts of cider mix. So what I'm going to do is I'm going to find out what is the amount of water per 1 part of cider. So when all of these are equal to 1 part of cider, how much water is that? And the one that has the least amount of water is going to be my strongest flavor. To do that, I'm going to have to divide. And I know that for Laredo, I'm dividing both by 2. So what this tells us is that for every 1 part of cider, Laredo puts in 6 parts of water. For the next one, I'm going to be dividing both 16 and 6 by 6. Now I know that that is not the nicest division problem to do, but we can go ahead and we can use our calculator here to make it a little easier on us. So 16 and dividing that by 6, and that gives me 2 and 6/10 repeating. So 2 and 6/10 repeating. So for every 1 cup of cider, she puts in 2, and that ends up being 2/3 of a cup of cider. And then here, again, I'm dividing both of these by 6, but now it's 15 being divided by 6. And I can take a look, 15 divided by 6, and I get 2.5. So even though it's not by much, we see yet again that Franca has the strongest mix, because for every 1 cup of cider, she only puts in 2.5 cups of water, whereas Milton puts in 2 and 6/10 repeating, and Laredo puts in a whopping 6 cups of water per every 1 cup of cider. So this is how we can go ahead and use our equivalent ratios to determine the strength and use comparisons with them.